Does this work? Hello? Good, because I don't hear it over here. Okay. Hi. I'm Sebastian. For about 30 years now, I've been programming computers. I still like it. Maybe that changes at some time in the future. I don't know. When I'm not traveling to nice cities like this one and present to people like you at a conference or an event like this on things like PHPUnit and others, I help teams build better software with PHP and everything around PHP. That's what I do. For that, I founded a company almost 10 years ago together with two friends from the PHP community, Arne Blankatz and Stefan Priebsch. We are the PHP consulting company, and we basically do everything that has to do with knowledge transfer surrounding the PHP ecosystem. That is a close-up photo of the first computer I ever connected to the internet with. Back then, I used a 50K modem dial-up to call a university and dial-up, and that's kind of dark. I hope that gets better at some point. That's an Amiga 1200. It was not my first machine, but it was the one that I connected to the internet with. And it's also the first computer that I did some. Well, back then, I thought I was doing internet programming. Nowadays, I would not call that internet programming anymore because I was basically just doing very basic HTML, HTML2 at the time, using a browser on the Amiga to get my feet wet. And whenever I made a change in the text files in the HTML, remember, that was, I don't know, when was this? 96, 97. There was no JavaScript, there was no CSS, there was just HTML and tags that we got rid of since then to make things move and have colors and such. And every time I made a change in the text file in the HTML, I would go back to the browser window and hit F5 to see whether or not the change that I had just made had the desired effect. And that was my feedback loop. And to a lot of people like me and a lot of people that got started that way in writing HTML, doing websites, that was the feedback loop for a very long time. You change something in HTML, later on change something in HTML, CSS, or JavaScript, hit F5 in the browser and see whether or not the change had the desired effect. That works as long as you do not have actual code running on the server that has side effects other than you get something that hopefully looks nice in the browser, meaning you have state change somewhere. Maybe, or hopefully, if you have an e-commerce site and you hit the final buy button in the checkout process, you perform payment operations. Somewhere in a database you store that you now have one less of that item in inventory, and then you need to send it out somewhere, and you need to tell somebody about that this needs to be sent out. This is not a change, or when you're working on that, changing the code that drives that. That is not a change that you can verify by simply pressing F5 and look whether or not you see the right thing in the browser. So we need to look a little bit deeper, and by looking deeper, I do not mean opening your computer and look what's inside. We need to look what happens on the code level. So what a lot of people did was, okay, I'm working on a piece of code, I'm changing it a little bit, and I put a print R or a var dump or an echo or a print statement in the code around the area where I just made a change to print out some information to get an idea for whether or not the change that I had just had made led to the intended outcome. And yes, that is also a feedback loop, but I would argue that that's not the feedback loop you want. That's not the feedback loop you're looking for, to say it with some movie quote. And don't open your computer and put Lego figures onto your main board. It looks funny, but don't do that. So we need a different feedback loop. And a while ago was this idea, okay, I have my code, I make changes on my code, I put in temporary statements for debugging, for figuring out whether or not the change that I have just made has the desired effect. what if I don't have that code that tells me that it works correctly as a temporary thing, but keep it for the future so that tomorrow, a week from today, next month, a year from now, I can rerun this and get the feedback, yes, any other change that I have made since then did not break this thing that I wrote today. Obviously, this is not something that we can have in the same place as the code that does our logic. The code where we before just put in a debugging statement like a print R or a var dump or a print. We need to put that somewhere else. We need to put that in a separate piece of code, into a separate script that I can run for testing purposes. The next step was, or the next realization was, what if I not only put that information, what I expect to happen there, that I can just run it and see a visual feedback that I can look at, read, understand, and make a decision whether or not that's the right thing. But what if I can write down my expectation in a way that the computer can automatically verify it whenever I run this thing that would become known as a test? So we want something that a machine can not only run, but also automatically verify. And the first time in computing or software engineering that we know of today that this idea came up was in the Smalltalk community, and for the first time a framework was created for writing these test things and to automatically execute them. That was SUnit for Smalltalk, and that began a long history of these testing frameworks, these XUnit, as they're called nowadays, testing frameworks that allow you to write tests and then give you tools to run these tests. PHPUnit, which I started to work on at the end of 2000, beginning of 2001, depending on how you count working on it. So for a very long time now, I've been doing this, and the reason why I started PHPUnit was, back then I was still in university, was really lucky that I was exposed to JUnit and SUnit really early on, and I liked the idea of writing down my expectations for how the code should behave, how the software should work, and then be able at any point in time while working on it to not push a button, but run a command on the command line that would tell me, yes, you have not broken anything in the last 10 minutes, which is a really empowering thing, and it gives you confidence in your code, and it just feels better to work like that. So obviously at that time I was already using PHP, so the JUnit that I worked with at the university wasn't that much help for me, and so one day I got tired of waiting for somebody else to write something like JUnit for PHP, so I just started PHPUnit. So what is it? It's basically two things in one. It's a framework on the one hand that gives you the means to really easily and conveniently write down your expectations that you have on your code in code. And on the other hand, it's a tool that executes these tests and provides useful results. Like any other framework, a testing framework like PHPUnit is built around a certain set of conventions that you should follow if you want to get the most benefit from using the framework and the tool. And that's really hard to read. Sorry about that. And a lot of code is missing on the left. Okay, so I don't know how to fix that. Let me try for a couple of seconds to fix that, but no promises. Because there are a lot of things that I'm good at, but CSS is not it. Can't seem to find it. Nope. Sorry. The contrast is really bad. Oh. You want me to? Well, lowering the resolution is not going to help with the colors.
No, the colors is impossible to change. No.
So, what resolution do you?
430. 430.
Yeah.
This one. Yes. You can change color.
Okay. At least it's 1024 by 768. I recently gave a presentation using a projector that could only do 640 by 480, and those are still around. And that's a projector that's much bigger than that one. A huge thing that made a lot of noise. So anyway, a testing framework like PHPUnit is built around a set of conventions, and one of those conventions is that it tests for something that is named email go into a class that is named email test. PHPUnit itself does not care one bit about what you name your tests. Please do yourself a favor and think about names, about good names for your tests, and not just limit that to tests, but also always think about naming things when you're writing software. Naming things like classes and methods and variables is one of the hardest things in software engineering, but it's also one of the most important ones. If your names don't make sense today, the code will not make sense to you tomorrow or a year from now when you look at it again, or when a coworker, a teammate looks at the code that you wrote today. Okay, so the test for something that is named email go into a class that is named email test. Convention number 1. Convention 2 is such a test case class like email test extends PHPUnit framework test case. Next convention is that a single test is a public method where the name begins with test. And again, yes, you could name your tests test 1, test 2. Don't do that. Find a name that describes what exactly you want to verify with this test, what you want to describe with this test, what you want to test. And yes, from time to time, I see test suites with hundreds and thousands, tens of thousands of tests even, that do not have good names, that actually have test 1, test 2, test 10,024. Don't do that. When such a test fails, you do not know from just looking at the name of the test what went wrong. Inside your test, you can do pretty much whatever you want. In this case, we create a new email object using a string, and then use a so-called assertion method that is provided by PHPUnit to verify the return value of that operation that we're testing. We want that return value in that case to be an instance of the email class. I mentioned earlier, PHPUnit is two things. It's on the one hand the framework for writing these tests, and on the other hand it's a command line tool to execute these tests. So we can switch to the command line and say PHPUnit, please run the tests you find in the email test class. For each test that is executed, PHPUnit will print one character of output to indicate progress. In this case, that's an E for error. You do not want to see E's. You do not want to see F's for failures, that we'll come to in a little bit. You want to see dots. Dot means successful. At the core of the philosophy of all these test frameworks, these XUnit test frameworks, is the assumption that all tests pass all the time. And when that is the case, there's only very minimal output, only the progress information, and then at the end, 1 or 2 lines of summary. I ran this many tests, these many assertions were performed, everything was fine, maybe even some like PHPUnit does. It took this amount of time and this amount of memory to do this. In this case, we get an E for error. An error is something unexpected. It's usually a PHP error or an unhandled exception. Usually there's something really wrong, either with the test code or more likely the code you're testing. So in this case, we run into a PHP error. You're trying to use a class in your test that does not exist, or at least PHPUnit cannot find it, the email class. So that's why PHPUnit says, hey, there's something wrong with this test. I cannot do that. To remedy that, we need to write the email class, write a minimal amount of code to make this one test that we just wrote work. Just an email class that gets a string in its constructor, assigns that string to a private attribute, and that's it. Then we can run our test again. This time the test is executed successfully, which means we get a lot less output, as I mentioned earlier. Just get a single dot for the output, progress, and then took 26 milliseconds to run, took 4 megabytes to execute. Everything is okay, 1 test, 1 assertion. That is a feedback loop, and to me, after working for a very long time using tests, this is the only feedback loop nowadays that makes sense to me. I cannot work, well, that's not true. For everything that is not PHPUnit, I cannot work in any other way than having these tests that are my feedback loop that guide me step by step. For PHPUnit itself, it's a little bit more complicated. To this day, I have not figured out how to write at least the tests first for when I work on PHPUnit. That's a chicken egg problem that I have not figured out yet. But I'm open for ideas. Maybe somebody at some point can point me in the right direction. So what I just demonstrated was not just how to write tests using PHPUnit and how to run them with the PHPUnit command line tool, but that it's also possible to write the test first, to let the tests drive the development. That's test-driven development. And we can continue a little bit. Write the next test. Test can be used as string, so I want to be able to use these email objects, these email value objects as a string. I run that, and PHPUnit this time not marks this test as an error with an E, but using an F for failure. Remember, error was when something unexpected happens, like an unhandled exception or a PHP error. F, or failure, happens when an assertion failed. In this case, we have an assert equals in the test code, which says, I expect that this actual value that comes as a return value from some operation matches this expected value. And this is not the case. We're trying to compare an email object to a string. That does not work. PHPUnit tells us that this test has failed. Simplest thing that we could possibly do to make the test pass is implement an __ toString method that is automatically called when we try to use this email object as a string, and then the test passes. Final test that I want to add is test cannot be created from invalid email address, and that shows something new. Before, we only looked at return values of functions or methods and how to test them with, for instance, assertions like assert equals. There are many of PHPUnit comes with a large array of these to test very specifically the thing that you want to test, and it's a best practice to always use the most specific assertion possible for what you want to express. There's another thing, or a thing different from testing return values, is testing things when something goes wrong, testing exceptions. So in this case, we want to test that the email object cannot, or that an email object cannot be created with an invalid string, with a string that does not contain a valid email address. And for that, we do not use an assertion. Instead, we use an expectation and say, for this test to be successful, we expect that an invalid argument exception is raised. And if that exception is raised, great, test is successful. If that exception is not raised, if, for instance, no exception at all is raised or a different exception is raised, then the test will be marked as failure because the expectation was not met. There are only 3 different things that you can test, or that you need to be able to test. First is return value of a function or method. Second is a different communication channel between the method or function that you called and the place in the code where it was called, in the case of an error, using exceptions. And the third one is side effects. And side effects can be as simple as one object, the object that you test calls a method on a different object, or the object that you test communicates with the database, with the file system, with any other type of external system. That's where things get complicated. But for now, we just run our test class again. Tells us, hey, that exception is not thrown. We need to implement the check whether or not a string contains a valid email address. And once we do that and run the thing again, it passes. So all those tests that I showed so far are unit tests. Every test that you can write or that you can implement and run using PHPUnit will be a unit test. Of course, when I started the project almost 18 years ago, I named it PHPUnit after JUnit, and I only cared about unit tests at the time. It was very similar for the creators of JUnit, as it was very similar for the creators of JUnit and CPPUnit and all these other ports of the XUnit idea. Over time, I realized that there are more than just unit tests that are useful in a software project, and I realized that almost all of them can also be implemented using PHPUnit. So the name does not really match for these other types of tests, but you can still implement them. That's one way of looking at it. The other way of looking at it, just because you're looking at a test that was implemented using PHPUnit and can be run using PHPUnit does not mean that it's a unit test. So what is a unit test? A unit test is a test that exercises or verifies only one unit of code in isolation from everything else. That unit is usually an object. A unit test is also a so-called dynamic test. Dynamic test meaning you're testing the software by executing it. There are many different ways of, or many different categories or subcategories of dynamic tests. Unit test is a dynamic test, but also using a tool such as AB or Siege or JMeter to do performance and load and stress testing of your application as a whole is a dynamic test because the software is being executed. The opposite of a dynamic test would be a static test, which is testing aspects of your software without executing the code, just looking at the code. That's what static code analysis does. That's, for instance, what your IDE does while you're typing and telling you, hey, you're using a class here that does not exist, or you're using a method on a class that does not exist, and so on. The original goal, and still the main goal of all this dynamic testing is, and especially that of unit testing, is verification through execution. I execute a piece of code to verify that it works correctly. But you can look at the same thing, at the same test from a different perspective, and not just think about it as, yes, I'm testing, I wrote this test to verify that this object, this method of the object works correctly. You can also look at this same test as executable documentation. You have documented how you, as a developer, at the point in time where you implemented this functionality, understood what the functionality should be. And this is where the naming of the tests comes into play. If you only have like test 1, test 2, test 3, and so on, and not things like we had in the email example, test can be created from valid string, cannot be created from invalid string, and so on, then a lot of information is lost. Of course, in the simple example of such an email value object, the purpose and what the thing should be and how it should work can most likely be very easily be understood from reading the code again. But think about more complex stuff where you have different types of contracts, for instance, with different conditions for different customers. And if that is not documented in easy to understand names, then you're going to have a hard time figuring out a year or two later what the purpose of this piece of your application was supposed to be. You can even have a different look at it and think of it as executable specification. It's just going one step further than just executable documentation, meaning if you do test-driven development, you specify beforehand, before you write a single line of code of the actual implementation, you very strictly define what this thing should look like, how you want to invoke it, what is the right name for it, what parameters do you need, what type goes in, what are the names of those parameters, and what's the type of the return value, and so on. Makes it really easy for somebody else to work with the code, because he or she can just run the tests, get an idea for what each of these tests are, what they are about. PHPUnit supports that idea through a different kind of output as a checklist, using the conventions for naming the test classes and the test methods. So this is about email, okay. Get the checklist of what this unit of code, what this small wheel in the gearworks of my entire application is responsible for. And if I have to work with that for the first time, I can just look at this output and say, okay, that sounds interesting, that sounds relevant to what I'm about to do. Look at the code of that test and get an example for that specific aspect, how to use that object in a different place. The primary task of a developer is not the writing of code, but to understand the problem. Every time I say that to a team of developers, it comes as a big revelation, because most of the time they think, I'm a software developer, my purpose, not necessarily in life, but at my job is to produce code, and when I'm not producing code, I'm not working effectively. No, your job as a developer is not to produce code. Your job is to understand and solve a problem. And yes, most of the time, The solution to that problem might involve the creation of code, but be responsible about it. Not everything needs to be implemented in code. The writing of tests, and this is a very personal thing. Like I said earlier, after now 10, 15 years of doing test-driven development, it's really hard for me to work differently. And this is part of an explanation for why that has changed so much for me. For me, the writing of these tests before I go into the actual implementation, that is the production code, helps me understand the problem I'm supposed to solve step by step. Step by step, I can approach that problem. Step by step, I can solve it. Step by step, I can document my thought process and the requirements in test code. Yeah, the tests drive the development to trigger the required thought processes, not as an end in itself. I don't do this because everybody tells me that this is awesome and I'm not a good developer if I don't do that. I do it because right now, after 10, 15 years of doing that, it's the only thing that reliably works for me when trying to understand and solve problems. Yeah, others have put it a little bit differently. One of the books that I think every software developer should have read at some point in their career is the Clean Code book by Uncle Bob Martin. And in there, at the beginning, he asks several other people, what do you think is clean code? And the one explanation that resonates the most with me is the one by Dave Thomas, which says clean code can be read and enhanced by a developer other than its original author. Yes, that's nice, but clean code, I would go even further and say clean code is code that you write today and can still understand tomorrow and a year from now. Happened to me so often in the almost 18 years now working on PHPUnit that I have to look at one area of the code that I haven't touched in 3-4 years to fix a bug, to implement a new feature, and I look at the code and I think to myself, how could this ever have worked? What was the person thinking who, oh wait, that probably was me. Now I don't understand it anymore. Avoid that. And tests are a really good, or unit tests are a really good way of forcing yourself to avoid a lot of these pitfalls that lead you to code that is not clean. It has unit and acceptance tests. It has meaningful names. There they are again, the names. Naming things is important. There's a lot of power in names. And minimal dependencies which are explicitly defined. Steve Freeman and Ned Price put it a little bit different spin on it. For a class to be easy to unit test, the class must have explicit dependencies that can easily be substituted. If the dependencies can be easily substituted, meaning dependency injection is used to handle the dependencies, then the third thing that you need to be able to test, aside from return values and exceptions, side effects, becomes a whole lot more manageable and convenient to test. If you cannot swap out the code that talks to your database for something that looks like the code that talks to the database, you will have a really hard time test important aspects of your application. If you cannot swap out the piece of code that talks to an external service for testing purposes, then you will have a hard time to test those parts of your application that talk to an external system without needing to talk to the actual external system. I'm almost out of time, but one last thing, as I mentioned earlier, there are not only unit tests, there are many more different types of tests. Not going into the details what all of those are, but it really helps to answer or to keep these questions in mind when writing a test. What do I want to achieve with the test? What is the answer that I want, or what is the question that I want to answer with this test? And if you do not come up with a good question that this test answers, you probably do not need the test. Or have not understood the problem that you're currently working on fully. Maybe you're thinking in too big of a scope. Slice the problem down even smaller, make the test smaller, take smaller steps to understand and solve the problem. One of the most important questions when implementing tests is, how much code do I need to execute to answer the question that I want to answer with this test? The less code you execute, the faster the test is. The less code you execute, the more precise the information will be in case of the test failing. When you execute everything and the test fails, that's really valuable information that something currently is not working, but it does not help you one bit in pinpointing the root cause, where you need to start debugging, where you need to start to look for solving the problem. The less code you execute, the more precise the result. How do I want to formulate a test? How do I want to write down the test? Do I use a programmer-friendly approach like unit tests in the form of PHPUnit, for instance, as a tool? Or do I want to write down the tests in a different language, in a different format that is not only compatible with developers, but also with non-developers? When do I write the tests? And that depends, of course, a lot on the context that you're operating in. If you're writing new software, then I would encourage you to at least try test-driven development. In an existing project, it's going to be hard to introduce test-driven development there, but you can use characterization tests, for instance, to get started with testing the existing code and try to write new code in, maybe not directly in a test-driven manner, but with tests in mind to make it easier to test them at some point at least. When do we execute the test is the last point, and most of the time you'll execute a test during development or before deployment or continuous integration, something like that. There are tests that make a lot of sense to run continuously in production, things like smoke tests to verify that the communication between your software and external systems currently works correctly. And now I'm out of time. So I spare you the drawing that I tried to make. Any questions?
Is a percentage of this time to do some test, like 40%, 50%, something like this?
Do you estimate if statements? Do you estimate switch statements? No, you don't. So you don't estimate tests. At some point, that sounds harsh and very fanatical, and I know that. But over time, or let me roll back and give you the answer in smaller increments. When you start to do something new, like using unit tests and using PHPUnit as a tool, the first step is to understand the concept and to understand the tool. At some point, and from experience, that's usually 1 or 2 months after a developer starts to use a tool like PHPUnit, there comes the point where they know most of the features that they need to write tests, and they know enough to run the tests in a way that makes sense for them at that point in time. That is a point in time where you do not need to think about the tool anymore. That's when you can actually start to think about changing the way you develop software, change the way that, for instance, you write the tests first, at least for new things. There are a lot of studies out there. And I think last year I gave a presentation at another conference for which there is a video available, where I, with Jeffrey McGuire, Jam, from the Drupal community, we did this together exactly to answer that question. And we looked at all of these studies that have been published in the last 20 years, since testing in general and unit testing in particular became popular. A lot of studies were made to look at how much longer is it. And the interesting answer is, or the good outcome of that is, in the first project that you do it, you will be depending on many different criteria, somewhere between 10 and 40% slower than not doing it. And that is because you're doing something for the very first time. In the long run, you will be a lot faster because you work with more confidence, because you lower the defect rate, you lower the number of bugs that you find in production, and you don't have to fix these bugs under an enormous amount of stress in production, but you find them before you put the code in production. You find them through the tests, and when you make the change to fix the bug, you have all the other tests that tell you that fix really fixed that one bug, which is important. Even more important is that fix for that one bug did not introduce another bug. The best way to think about these tests is as an investment into the future. Yes, it's really nice and helpful that they help me understand the problem, solve the problem in small steps today while I'm working on the code. It's even more important a month from now, a year from now, 5 years from now, to have these tests to verify, or to prove that I have not broken anything that used to work before. And it takes a while for that to pay off, which has in some part to do with that you need to learn the tool, need to learn the methodology and so on. But also, the biggest effect is over time.